everyone, welcome to Pepcoding. So the question that we are going to solve today is merge overlapping interval. First, let us understand the question and then we'll head over to the solution. So I'll take the question from here only. Okay, so what we are given today is a value n. Okay, for value n, we will be given an array of containing of n rows. Okay, and for each row there will be two columns and we will have the inputs given to us. So we are taking an example. Let's say we have 6 meetings. So we are saying n is equal to 6 in this case. We are given 6 inputs over here. So we have starting time and ending time for each. Starting time, ending time, starting time, ending time, starting, ending, starting, ending, starting as well as ending. So we are taking an example that let's say we have 6 meetings and these are the time schedules for all the 6 meetings. So we have a meeting where the starting time is 1, ending time is 8. For second it is 5 and 12. For third it is 14 and 19. For fourth it is 22, 28. For fifth it is 25, 27. And for last one it is 27 to 30. We are saying that we want to create a situation where we have to merge as many meetings as we can. Okay, so the output for this after merging becomes 1, 12, 14, 19, 22 and 30. How did it happen? Let's see. So we have 1 to 8, 5 to 12, 14, 19, 22, 28, 25, 27 and 27 to 30. So we are going to work with these. I am saying that I have first meeting ranging from 1 to 8. Okay. Let's say this is 1 to 8. Then the second one I have which is going from 5 to 12. So as you can see, these two are overlapping each other, right? I have the first one as 1 to 8, 5 to 12. So 5 is lying somewhere between the starting time and ending time of the first one, right? So these kind of meetings where the starting time of the second meeting is less than the ending time of the first meeting, we can merge these meetings. Let's see for others as well. So we can merge 1, 8, 5 and 12. So this becomes 1 and 12. Okay. The ending time becomes the greater one, right? Now the next one we have 14 to 19. Now 14 does not lie over here, right? 14 is greater than, I'll move it over here. Okay. So 14 is greater than 12, right? So 14 will lie somewhere over here. Here. Now 14 to 19 is not overlapping with the rest of the numbers which we have already been given as an input. So this one will not make any change. It cannot be overlapped. Till now it cannot be. So we have 1 to 12 after merging, 14 to 19 as it is. Then after that we have 22 to 28. Let me move this to the side so that we can understand this easily. Over here I'll move. Okay. Now for this one, next we have is 22 to 28. We have done these three and we are working with 22 to 28. Again 22 to 28 does not lie anywhere over here. So we are not taking this for merging, right? Till now it cannot be merged. We have 22 to 28. So we are going to put this as it is. After that, the next one which we have is 25 to 27. So 25 to 27 lies within this, right? 25 is also less than 28 and 27 is also less than 28. So in this case, we have a condition where the starting as well as ending timing for 22 to 28 will not change, right? So over here we have 25 to 27, which will merge within this and it will remain as it is. After that, the next one which we have is 27 to 30. So now we have same starting time, but the ending time becomes different. So we have 27 to 30. Again, 27 is overlapping with the one for 22 to 28, right? So over here we can merge these two. So we'll have 22 to 28 and now the ending time becomes 30. So we can change the ending time after overlapping and this will become 30. Okay, so these will be the final three values which we will get. We merged 1 to 8 and 5 to 12 and we got 1 to 12. Then we merged for 14 to 19, we could not merge it anywhere, so we left it as it is. Then we merged the remaining three, that is 22 to 28, 25 to 27 and 27 to 30. These three merged and formed 22 to 30. So this is how merge overlapping works. This is what the question wants us to do. So now we'll understand how we are going to do this. So we are going to do this using, first let us bring the question as well as answer over here. So we have this. How we are going to implement this question? So first what we are going to do is we are going to sort these. Okay, as you can see over here we do not have sorted values, so we are going to sort these. So it becomes 1 8 5 12 14 19 22 28 25 27 and 27 to 30. So this is what we are getting. Okay, how did we sort this? We sorted it on the basis of the start time first, and if at all for any two of these start time is equal, we'll sort them on the basis of its ending time. For this also we'll work in the code. First, let us assume that we just sorted it. So what we are going to do is we'll create a stack. Onto this stack I'll push my first pair. Okay, so I pushed 1 and 8. Now I'll come for 5 and 12. So for 5 and 12, it will check, is the starting time of this one less than the ending time of the one on the top of stack? That is 5 less than 8? Yes, it is. In this case, we can merge these two. So what will happen is that this is going to now become 1 and 12. We changed the end time to the one which was greater between the two. So it became 1 to 12. Okay. After that, we are done with these two. We'll now go for 14 to 19. Check again on the top of stack. Is 14 less than 12? No, it is not. So we are going to simply push 14 and 19 onto the stack. Now check for 22. Is 22 less than 19? No. So we are going to simply push it onto the stack. Then we are checking for 25. Is 25 less than 28? Yes, it is. So we are going to remove this from here. And 25 becomes overlapped over here. 27 is also less than 28. That is, the ending time of second one is less than the ending time of first one. So we will take the greater end time. Okay. So we are going to put 22 to 28 as it is after merging these two. Now I have 27 and 30. Again we'll check 27 is less than 28. So we are going to merge these two. Remove them. Starting time remains the same, right? For ending time, now we'll check which one is greater. So 30 is greater than 27. So we are going to push 30 onto the side. Now we've gotten the final values because we do not have anything over here, right? So we've gotten the final values. But as you can see that in the output, I want this value to be on the top, right? Now it is at the bottom of the stack. And the way stacks work, if I pop from the stack, 22 to 30 will be popped first. So what I'm going to do is, for this, I'll create another stack. And in this stack, I'll put these values. So I'll pop 22 and 30. I'll put it in this stack. I'll pop 14, 19, push it in the second stack. And I'll pop 1 to 12 and I'll push it onto the second stack. So this was my first stack. This was my second stack. Now when I'll give the answer, I'll give for the top values. That is first 1 and 12 will be printed, then 14 and 19, and then 22 to 30. So now we are going to try to code this. Okay. Over here, we have been given a function. So the first thing which we have to do is, now in this case, we really need to create a pair class. Why we need to create a pair class is because I want two things, right? I want a starting time as well as I want an ending time. So I'm going to create a class pair, and in this class I am going to take two things. So we have a starting time and we have an ending time, and I'm going to give a function for this. And dot et will be equal to et. Okay, so I created a pair class which can now easily give to me starting time as well as the ending time. Now I'm going to create an array. Okay, in this array I'll store these pairs of starting time as well as the ending time. So I'll create an array of pair type. Okay, and it will be a new array, and over here what will be the length of this array? It will be equal to the length of the array itself, right? So it will be equal to array dot length. Let us store the value of array dot length. Now what I want to do is that I want to retrieve the values from the array into my pair array, right? So I am going to start from 0 and I'll move till n, and within this array, that is pairs of I'll create a new pair every time. So the starting time for this array, that is pairs array, will be equal to the number at the 0th column for a given row, right? And the ending time will be equal to the number at the first column of the given row. So this is how we created our pairs array. Now we need to sort this array, right? As I discussed, we will have a case where the elements or the values which will be there in the pairs array will not be sorted. So we need to sort them. So I am going to sort this array. Now I am going to create a stack of pair type. Okay. And in this stack, I am going to push the element which is present on the 0th position of the pairs array. Right, it will go as it is because there's nothing for it to be compared. So I am going to push pairs of 0 onto this. Now I am going to start moving from the first position of the pairs array, right? So I'll go for until the length of pairs, right? Okay, now within this, I want to check the current item which I'm checking and the top of the stack. So I'll create two pairs. So I have first pair top, which will give me the top element of the stack, and the second one will be the current pair which I am looking at. So it will be at pairs of I, right? I'll check whether the starting time of current, if it is greater than the ending time of the one at the top of stack, in that case, what I'm going to do is I'll simply push this pair onto the stack, right? So the current pair will be pushed onto the stack. Otherwise, if the starting time of the current pair is not greater than the ending time of the top of the one on the top of the stack, it means that it can be merged, right? So starting time remains the same. We don't need to make changes to it. The ending time will now become the greater out of the two. So it will become mat.max, current dot ending time, and top dot end. So this is how we created the changes in the stack, right? Okay. After that, now as we discussed, the stack is in the opposite order of what we want it to be. So we are going to create another stack of pair. Okay. And let's call it result. So we have a new. But first thing which we need to do is, when we were sorting the pairs array, how did we sort it? We were checking for the starting time, and if the starting time for any two were similar, we were checking for the ending time. We are not going to get it done by itself, right? It's not going to happen by default. So we need to do something in the code itself to be able to get the sorting done. So what we are going to do is that in the pair class itself, we are going to use an interface which is known as comparable. The comparable interface allows us to get values on the basis of a comparison, and on the basis of that we can sort the arrays, right? So we are going to compare it, and the type will be pair because we are using the pair class. Now when we use the comparable interface and I want to return certain value, I'll use a function which is known as compare to. And who are we comparing with? Another pair. So I'll take this as other. Okay. What we are checking is whether the starting time of the current one is greater than the starting time of the other one. So if this dot st, obviously if it is not equal to other dot st, that is, if the starting time is different, then only we can compare them, right? So we'll return this dot st minus other dot st. What this will return to me is that if in case this, that is the current starting time, is less, then it will return if this dot st is greater, it will return to me a positive value. Okay. If this is less, it will return to me a negative value. Okay. And if it is not equal, that if these become equal, it will simply return to me 0. Okay. Now, there will be a situation where starting time of two elements or two pairs can be equal. So in that case, we'll check for the ending time. So in that case, we'll return this is how the pairs array was sorted. If you do not implement this function, we will not be able to sort the pairs array and we might get the answers wrong. So we don't want that to happen. Now, going back to the solution, we created a result stack, right? So in the result stack, I'll put all the values from the original stack. So till the size of the original stack is greater than 0, I am simply going to push onto the result stack after popping from the original stack. Now we are done with the result stack. It has been created and the original stack is now empty. Next, we want to print the answer. So I want that while the size of result is greater than 0, I'll keep on creating a pair, right, after popping from result, and I'll print the starting time as well as the ending time of this pair. So for system.out.println starting time, and with a space I'll print ending time. Now let us try to run this program. Okay, so we have over here, it will be okay, so the answer was accepted. Now we are going to try to submit this. And the answer is correct. Now we are going to do a very small dry run of this program. So what I'm going to do is, over here, I'll take this part of the code. Okay. So over here, I have this code. I'm going to erase the rest of it. Okay. Now what we are doing is, we are doing a small dry run of this program. How we are going to do this, let's see. So we have the input as well as the outputs ready for us, right? So see, first what we did was we created the pairs array, and in the pairs array I stored all the values and I already sorted them using the comparable interface of pair class. Now I have the values. It's something like this. 1 second. Become 5, 12, 14, 19, 22, 27, okay, 22 and 28, okay. So 22, 28, 25, 27 and 27, 30. So these are the values which I have now. Now what we are doing is, we pushed the value at the 0th position onto the stack. So I have a stack. On this stack, I pushed 1 to 8. Starting from first position, that is, we are starting from this position. Okay, we created a pair top which holds this value, right, 1 to 8, and we have a pair current which holds this value, that is 5 to 12. We'll check whether current dot start time, that is 5, is greater than 8. It is not, so we'll go to the else part, and top will now become max of current.et and top.et. So this becomes 12, right? So now top will change. This will now change and become 12. Okay. After that, we'll move to the next position. We'll check for 14. 14 is now our current pair and 1 to 12 is the top pair. So now 14 is greater than 12, right? So we are entering the if condition and we are simply pushing it onto the stack. So we got 14 and 19 over here. Moving on, we get 22. Again, the same thing happens, that 22 is greater than 14 or 19. So we are entering the if condition and we are going to push it onto the stack. Then we come across 25. We'll check, is 25 greater than 28? It is not, right? So we are going to make changes in the top position. We'll check which is maximum, 28 or 27. So we see that 28 is greater. So top.et remains 28. Then we come to 27 and 30. So is 27 greater than 28? It is not. So top.et is going to change. So we'll check, is 28 greater or is 30 greater? So 30 is greater. So this will change. And here we are going to get 30. Now the stack has been prepared. We are done with this loop, right? Now we create another stack. Result. We'll keep on popping from main stack and pushing onto the result stack. So here we got 22, 30, then we got 14 and 19, and then we got 1 and 12, and this becomes, the size becomes 0. So we'll do nothing with it. Now what we are going to do is, for this result stack, I'll keep on popping these, hold it in a pair. So I got it in a pair, 1 and 12. So 1 is the start time, 12 is the end time. I'll print them. And these have been popped. Then I work for 14 and 19. Similarly, I'll print 14, 19. This has been removed. And similarly, 22 and 30 will be printed. They are popped. So we are done with this also. So we will get our answer as we expected. So today we discussed merge overlapping. I hope you understood the question as well as the solution. Thank you for watching the video. Please like, share and subscribe to the channel.